In the last section, we're going to go ahead and explore the point-slope form. Now, this is going to be broken down into several parts, and basically in each part we're going to look at the same problems but talk about solving them using different methods. And from there you can pick the method that is most comfortable for you. In this first section, I'm going to present the point-slope form of an equation. In order to use point-slope form, you need to know how to plug in values for their indicated variable. You need to know how to solve for an indicated variable. You need to know how to find the slope given 2 points, as well as understand how to add, subtract, and multiply fractions. Upon completing this presentation, you will be able to find the equation of a line given a slope and a point, given 2 points, given a point, an equation, and a relationship. So let's go ahead and talk about point-slope form. Point-slope form, we have our formula, which is y minus y1 equals m times x minus x1, where m is our slope and the point x1, y1 is a point on the graph. Now this form is nothing new. This is actually a manipulation of the slope formula. So let's go ahead and see, where does this form come from? If we go ahead and look at our formula for slope, recall that our formula for slope is m equals y2 minus y1 over x2 minus x1. So we're going to manipulate this into point-slope form. In order to do this, the first thing that I want to do is get rid of my fraction. So I want to multiply both sides of the equation by x2 minus x1. If we do this, we get m times x2 minus x1. I want it in parentheses so that I know that I'm multiplying the whole thing by x2 minus x1. On the right side, my x2 minus x1's cancel, and I am left with y2 minus y1. Our last step for this, I don't know if you sat there and wondered, why do we do x2 minus x1 and y2 minus y1? Why don't we just do our 1's first and then our 2's? Well, the reason is because of point-slope form. Our last step in order to get this into point-slope form is I want to take my x2, y2, and instead of having it be a particular point on the graph, I want to make it any point on the graph, meaning I want to change them back to variables. In order to do that, we're just going to get rid of the subscripts. So we get m times x minus x1 equals y minus y1. And now all I want to do in order to get this into point-slope form is I'm just going to switch my equation around. So whatever was on the right, I'm going to put it on the left. Whatever was on the left, I'm going to put it on the right. And so this is where our formula comes from. Okay, so you don't necessarily need to know that, but just to show you, this is nothing new. We have seen this formula before. We've seen this form before. Okay, so now, what are we going to do with this? Now, we've talked about general form, and we've talked about slope-intercept form. And both of those are good starting equations. Also, we have that slope-intercept form is a good ending equation. Remember that so far we've always wanted to write things in slope-intercept form because it is the nicest in terms of being able to determine what our line looks like by just looking at the equation. So now, point-slope form, just so you know, this is a working equation. We never have any of our answers that start with this. And in fact, we never have any problems that start with this. It is a working equation. It means that we're going to be given information and we want to plug it into our form, and then we're going to manipulate our form into slope-intercept form. So our first step in order to do this is we need to find a slope and a point. The point is going to be given to you no matter what. Now, sometimes we will be given a slope, but we may be given other information. So our first step is to determine the slope if it is not provided. There are a couple things that we can do in order to do this. We can use the slope formula if we are given 2 points. Other questions that we might be asked will be related to parallel and perpendicular. And so if we are given an equation and being asked to find a parallel line or a perpendicular line, remember that parallel and perpendicular is a relationship between slopes. So the first thing we will need to do is find the slope of the given line. In order to do that, we want to rewrite the given line in slope-intercept form. Recall that parallel lines have same slope, so if we are finding a parallel line, we keep the slope. If it is a perpendicular line, remember perpendicular lines have opposite reciprocal slopes. So we will want to change the sign and flip the fraction if we are finding a perpendicular line. From there, we want to plug our slope in for m. We want to plug the x-coordinate of a point, or the point, into x1, and we want to plug the y-coordinate of a point, or the point, into y1. From there, we want to rewrite in slope-intercept form, meaning solve for y. So our first step for that is to distribute to clear the parentheses, and then isolate y by moving the constant term to the other side of the equation. Let's begin with example A. On this page, on this slide, we're going to go ahead and just look at some basic problems involving point-slope form. The most basic example is going to be given a point and a slope. So the first thing that I want to do is I want to start by writing out my formula. My formula for point-slope is y minus y1 equals m times x minus x1. So from here we want to go ahead and plug in numbers for their values. So I know that my slope is 4, that's going to be my m value. I also have that my x-coordinate for the point is -1, that's going to be replacing x1. My y-coordinate is 3, that will replace y1. So now we can go ahead and plug these values into our formula. When we do that, we get y minus, we said y1 was 3, equals m, we said was 4, times x minus x1, we said was -1. Now, generally, I go ahead and change it to a plus. I'm going to go ahead and do that in 2 steps this time. So we have x minus -1. So, my first step before I do anything else is I'm going to get rid of this minus a -1 and turn it into a +1. and rewrite my equation. We have y minus 3 equals 4 times x plus 1. Now in order to solve for y, we're going to use our solving steps. So my first solving step on this equation is I do want to clear parentheses by distributing. If we go ahead and distribute, the left side will stay the same. We still have y minus 3 equals. We want to distribute the 4 to each term. We get 4x plus 4 times 1 is 4. From here, I can go ahead and add 3 to both sides in order to get y by itself, and I'm going to add my constants together. I want to add it with the 4, not the 4x, since it's not an x term. So on the left, my 3's cancel, leaving me with just y. And on the right, I have 4x plus 7. And we're done. So now let's go down to one that's a little bit more challenging just because it has a fraction in it. But that's the only thing that makes it a little more challenging. Now, one of the first questions that I want to pose to you is, the purpose of this problem, do you know how to work with fractions? And the answer to that is no, which means that any of the fraction operations, you are welcome to use a calculator. I don't have a calculator with me, and I'm comfortable with my fraction. And so I'm going to go ahead and do these by hand. Now, if you want to know how to do the fraction operations on your calculator, if you are not sure, please be sure to bring it to class so that I can show you how to use the fraction features on your calculator. But as far as this problem goes, we're going to do exactly what we did on the previous problem. I'm going to start by writing my formula. We have y minus y1 equals m times x minus x1. And I want to plug in my values. So my slope is -3/4. I'm going to plug that in for m. -2 is the x coordinate of the point. That's going to go in for x1. And -5 is the y coordinate of our point. So I'm going to plug that in for y1. So now when we go ahead and plug these values into our formula, we get y minus -5 becomes +5 equals -3/4 times x minus x1 becomes, or minus -2 becomes x plus 2. We still want to solve for y. So again, my first step is to go ahead and clear the parentheses. I want to distribute. So my left side of the equation will stay the same. We have y plus 5. On the right side of my equation, I want to distribute the -3/4. So I get -3/4 x. And then I want to come off to the side and calculate what is -3/4 times 2. Remember that we are distributing, we should be multiplying. So I want to multiply -3/4 times 2, and I'm going to write 2 as 2 over 1. From here, remember that to multiply fractions, we want to multiply straight across and cancel. And remember, you can do these in either order. I prefer to cancel first, so I note that 4 and 2 are both divisible by 2. So if we divide both of these by 2, I get 4 divided by 2 is 2, and 2 divided by 2 is 1. If I go ahead and multiply straight across, I get -3 over 2. Now I'm going to go ahead and bring that back into my equation. And then finally, my last step in order to solve for y is to subtract 5 from both sides. So I'm going to subtract 5 on the left, And I'm going to subtract 5 on the right, and again I want to make sure I subtract it from the constant term. So on the left side we have our 5's cancel, leaving us with just a y. And on the left side we have -3/4 x. And again, for my constant term, I'm going to come over to the side and subtract 5/1 from -3/2. Now, what is our rule for subtracting fractions? Remember that with fractions we need a least common denominator. What would be my least common denominator if I already have denominators of 2 and 1? Hopefully you said 2. So I want to multiply the second one by 2. The first fraction I can leave it as it is, since it already has a denominator of 2. So I get -3/2 minus 10/2. And if you struggle with having a negative in the middle and a negative on the top, remember that you can go ahead and change this to plus a negative. We do have same signs, so we are going to add, keep the sign, keep the denominator. So we end up with -13/2 for our y-intercept. So our final equation is y equals -3/4 x minus 13/2. And this is a perfectly fine equation. We're not going to be graphing it. You can have y-intercepts that are not necessarily nice numbers. The important thing that we are trying to do in this section is equation manipulation. Okay, so that takes care of our 2 basic examples. So now let's go ahead and jump into some that are a little bit more complex. So these next set of examples are going to involve problems that are 2 steps. We're not going to be given a slope. We're going to have to find a slope on each one of these. So let's start with example C. I want to know what is the equation through for -3 and -2, 6. So again, the first thing that you have to keep in mind when using point-slope form is you have to have a point and you have to have a slope. Well, I have points. I need a slope for this line. So my first step is to use my formula for slope. Remember the slope formula, I want to subtract the y coordinates over, subtract the x coordinates. So from here, we want to go ahead and plug in our y's and our x's. I'm going to label this first point x1, y1. I'm going to label my second point x2, y2. So when we plug in, we end up with m equals y2 was 6 minus y1, which is -3. I'm going to change that to a +3, since we have minus a negative, over, since I did right minus left on my y's, I want to make sure that I do the same thing on my x's. So we did 6 minus -3. For my x's, I want to do -2 minus 4. And we simplify. So we get m equals 6 plus 3 is 9, over -2 minus 4 is -6. And to make it as easy as possible, let's simplify our fraction. We can divide by 3 to the top and the bottom. We get 3 over 2, and I still need my negative sign. I'm going to move the negative sign up to the top or the front. Okay, so all we have found is our slope. So now what we want to do is we're going to want to use our point slope form. Remember that our point slope form was y minus y1 equals m times x minus x1. Now for this, I pose the question to you, does it matter which point I use in my equation? And the answer is no. You can choose either point to plug in. So which one is going to be easier to work with? That's up to you. I'm going to go ahead and use the first point, but again, it does not matter. This is going to be my x1, my y1, and we have our m is -3/2. So if we go ahead and plug in, we get y minus -3 becomes y plus 3 equals m -3/2 times x minus 4. So from here, let's go ahead and simplify our equation and solve for y. So again, the first thing I want to do is distribute. The left side of my equation will stay the same. The right side, if we distribute, we get -3/2x. And now I want to multiply -3/2 times -4. So again, I'm going to come off to the side and do this as scratch work. First thing I notice is my negatives are going to cancel, and also 2 and 4 are both divisible by 2, leaving me with 1 and 2. So if we multiply straight across, we get 6/1, or just 6. So let's put that back into our equation. That makes our next step a lot easier if you simplify the fraction. We don't have to worry about fractions anymore since our constant term is now a whole number. So from here, in order to solve for y, I want to subtract 3 from both sides. And I am left with y equals -3/2x plus 3. And we're done. That is our equation. If you want to check your equation, one thing you can do is plug the second point into your equation and make sure that you get a true statement. If you get a true statement, then yes, this is the equation of the line that contains both of these points. If it doesn't, then you did something wrong somewhere. Okay, so let's move down to example B. So example D. Example D, we have through -3, 4, parallel to 3x minus 4y equals 5. So remember that parallel lines have same slope. So what we're saying here is I want the equation of the line through this that has the same slope as this line. So my first thing that I need to do is again find the slope, which means I want to find the slope of this line, and to do that I want to rewrite it in slope-intercept form. So if we go ahead and write out our equation again, in order to write this in slope-intercept form, I want to solve for y. So my first step is to get rid of my x term. I want to move my x term from the left to the right. In order to get rid of positive 3x, I want to subtract 3x. My 3x's cancel on the left, and I am left with -4y. Make sure that you're very careful with your signs on these. Lots of people have a tendency to drop them. And I'm going to put my x term in front, leaving me with -3x plus 5. The next thing I need to do in order to solve for y is to get rid of the negative 4. Since this is negative 4 times y, in order to get rid of multiplying by negative 4, I want to divide by negative 4. And remember that when we do this, we want to divide every term by negative 4. So on the left, my negative 4's cancel, and I am left with y. On the right side, my first term, the negatives cancel, leaving me with positive 3/4 x. And we don't have to do anything with the last term except for maybe move the negative up out of the denominator and make this a minus 5/4. Okay, so we did a lot of work to get it to this, and the only reason we wanted to do that was I wanted to know what is the slope. Our slope is 3/4. So we can rewrite this problem. What we are saying is I want the equation of the line through negative 3/4 with slope 3/4. So we're back to what we did on the previous slide. We have a slope, we have a point, and now we want to use our point slope form. So we have y minus y1 equals m times x minus x1. So my slope is 3/4. I'm going to replace m with that. We're going to replace x1 with negative 3. We're going to replace y1 with 4. So when we do this, we get y minus 4 equals positive 3/4 times x minus negative 3 becomes plus 3. Okay, so now we're back to our previous slide and we want to solve for y. So my first step is going to be distribute to clear parentheses. The left side of the equation will stay the same. We get y minus 4 equals 3/4 times x is 3/4 x. And if I multiply 3/4 times 3, I'm going to write it as 3/1. We cannot cancel anything. We have to just multiply straight across, leaving me with 9/4. So we have 9/4 as our constant term. From there, we want to get rid of the minus 4. The opposite of subtracting 4 is adding 4. So again, I'm going to come over to the side and I want to add 4 to the 9/4. So I'm going to start by writing it as 4/1. Again, I want a least common denominator for this. My least common denominator should be 4. So my first fraction, I can leave that the same. My second fraction, to get from 1 to 4, I want to multiply by 4 to the bottom. Whatever I do to the bottom, I do to the top. And I get 16/4. If we add this now, 9 plus 16 is 25 over, leave the denominator the same, 4. So let's come back to our equation. We have our negative and positive 4 cancel on the left, leaving me with just y. And on the right, we have 3/4 x plus 25/4, and we're done. Okay, so that's an example of a parallel problem. So now let's look at the last one, and the last one is perpendicular. So we want to find the line through 2, -1, perpendicular to 3x minus 2y equals 7. So similar to the parallel problem, remember that we have a relationship for slopes between perpendicular lines. So the first thing I need to do is I need to find the slope of the given line. So we're going to go ahead and start by writing out 3x minus 2y equals 7. We want to solve for y, and in order to do that, we're going to start by subtracting 3x from both sides. We get negative 2y equals negative 3x plus 7. Again, I want my x term first just so it looks like slope-intercept form. My last step is I want to divide. To get y by itself, I need to get rid of the negative 2. Since it's being multiplied to the y, I want to divide by it, and I want to divide every single term by negative 2. So on the left, we get our negative 2's cancel, leaving me with just y. On the right, my first term, my negatives cancel there as well, and I am just left with 3 over 2x. And I'm going to go ahead and bring my negative out of the denominator, and that's about all I can do there. So we have y equals 3/2 x plus 7. So the slope of this line is 3 over 2. But we want the slope of the perpendicular line. So what is the relationship between the slopes of perpendicular lines? Well, the relationship is opposite reciprocal. So the slope that we actually want is I want to change the sign from positive to negative, and I want to flip the fraction. So we get the slope of our line is going to be negative 2 over 3. We still have that we want it going through to negative 1. And so those are our pieces of information that we have to plug into our formula. So our formula again was y minus y1 equals m times x minus x1. We have 2 is going to be x1, negative 1 is going to be y1, and we have negative 2/3 is going to be our m value. So when we plug in, we get y minus negative 1 becomes y plus 1 equals negative 2/3 times x minus 2. From here, we're going to go ahead and do our process again. So the first thing I want to do is distribute to clear the parentheses. Left side will stay the same. If we distribute, we get negative 2/3 x, and negative 2/3 times negative 2, I'm going to write it over 1. We cannot cancel anything, so we want to multiply straight across. And we do end up with positive 4 over 3. Okay, so I'm going to bring that back to my equation. And then finally, to solve for y, I want to subtract 1 from both sides. On the left, my 1's cancel, leaving me with just y equals negative 2/3 x, and now what is 4/3 minus 1? I'm going to write this as 4/3 minus 1 over 1. We have a common denominator of 3, so I'm going to multiply bottom and top by 3. So we get 4/3 minus 3 over 3. We subtract the tops, keep the bottom, keep the sign of the larger number, and we get plus 1/3. and we're done. So, those are the different kinds of problems that you will see when we talk about point-slope form, or different things that we can do with linear equations. Okay, so when are we going to see this again? In future math classes, you will be asked to find linear models that satisfy different given conditions. And anytime you're asked to find a linear model that does this, this will usually involve using the point-slope form. So now, after you watch the next presentation, try the following problems on your own and bring your solutions to class, as well as any questions. Take a moment to pause this presentation so that you can go ahead and work on these before moving on to the next slide. Answer the following questions and attach to your notes to bring to class. How confident are you with the material presented in this section? What from this section needs to be explained further? And how much more practice do you need to be comfortable with the topic?